unsurprisingly, we do need to actually start off by putting things into the hash table. We'll also have to code a toString method up, but first we need to put things in. And we're going to basically, again, do this like we did with, kind of like we did with array lists, in the sense that we're going to code it, and then we're going to come up to an exception, and so we're going to have to implement more. It's important to see basically how I basically box myself into or box myself in with my code, and then I have to create an exception to it or new if conditions. So the idea here is, right, I need to do this in a couple steps. The first thing is that I have to create, I don't want to create the entry yet, but the first thing I need to do is figure out where I'm going to put this key. What index in the table I want to target. So int index is equal to, and the way I compute that is, first I have to throw it into a hash function, which I'm going to use the hash code function. Every single object has the hash code function, and it will return a value. It will return some hashable value. Hopefully they've implemented it themselves, but if not, I'm still getting something that's fairly unique and well distributed. But things like strings will have implemented their own hash code function, so this will work. And then finally, we need to mod this by the capacity of the table, right? In other words, this needs to be able to go up to some certain index, right? So if the cache table is size 10, we want this giant number that could go into the giant infinite array. Well, I don't have a giant infinite array because I don't have infinite amounts of RAM. So instead, I got to mod this to what we do have, which is capacity. So that will get me something from 0 to 9 rather than 0 to 2 billion. Okay, so that's where I would like to put something in. Okay, and the idea here is, if it's empty, I could put something. If it's empty, I could immediately put something in there. And I'll just remember to do size plus plus over here. But otherwise, I'll need to continue. So let's see here. Actually, the size plus plus I'll just put it down here for a while, because I'm trying to think about how to do this with returning the replaced value, because I've not actually done that before. So, all right, let's go ahead and do this terribly. While true. Yeah, that's super great way to do that. So the big thing though is that we're going to break out of this, and the way I'm thinking of this, we should never hit an infinite loop. Which is fairly straightforward. So if index if index, so let's see, if table index equals null. Okay, if we got to so that's one condition we've got. If the table index is equal to null, basically we've hit an empty spot. Great, we want to put our new key in there. Okay. Else it's not empty, but otherwise, let's see, what's the other condition? So the other condition is that there's an entry there, and the entry being there leads us to one of two possibilities. The entry already has that key value pair in it, or already has that key in it, in which case we want to replace it. Otherwise, keep going on. So else if table index dot key dot equals our key. Yeah, it's a bit big, but that's basically saying, hey, okay, if it's empty, great, we're at our ending condition. Found an empty spot. This is my spot, or rather, my key is already here, this is my spot. Update, but update value. Okay, that's my other condition. Found an empty spot. My key's already here. This is my spot, but I need to update the value. Otherwise, what do I have to do? I need to do linear probing. Okay, those are my 3 conditions for this. Okay. So what we are going to do, yeah, I don't need any of that. Okay. So found an empty spot. Great. So if I found an empty spot, then what I need to do is I'll increase the size because I'm putting a new entry into the table. Okay. And then I need to then all I have to do is say table index is equal to new entry of the key value type, the KV type, and key val. So that's actually fairly straightforward. So if I found an empty spot, great, that's what I want to do. So stick a new thing there and increment the size, and I'll return the thing that was previously there, which was nothing. Return null. That's an intentional return null, and that will break out of this while loop. Otherwise, we're currently in the spot we want to be in, or sorry, we found our own key, right? My key's already here, but I need to update the value. What I do is I say v old is equal to table.key.value, and then table.index value, or table index value is equal to value, the new value. So store the old value in old, replace it with the new value, return old. Break out of that. Do not increment the size here because guess what? We haven't incremented this. We haven't changed the size at all. We haven't changed the size at all here. So we're just replacing a value here. Okay. So finally, otherwise, what we need to do is that we need to go around again. We need to do linear probing here. Okay, probe for new index. And for here, all we have to do is say, now, this is part of the reason why using index++ can be hazardous. Not, because we have to use a mod operator as well. Again, what we're going to do is we're going to say index is equal to index plus 1 with parentheses here. And parentheses are important here. Mod. And we don't really need an else here because that's kind of implied. Make it readable. Mod capacity. So here we're going to increment the index, and if we go out of bounds of the array, in other words, we get to capacity, then this will bring it back around. Okay, now how do I ensure this is not going to be an infinite loop? Well, this will deal with the fact basically that eventually what's going to happen is that we need to resize this, and there's always going to be empty slots here because of the max load. And once we put it, and we'll have to put an if statement here to make sure that it doesn't get too big. And when it gets too big, we're going to rehash. Otherwise, this will turn it into an infinite loop, and that would be bad for us. So found an empty spot, put it in. Right. We'll get back to this. We still have some more to code, but what I'm going to do now is I'll just go ahead and write up the toString function to begin with.